Humanity's most powerful space observatory, the James Webb Space Telescope, may have detected something extraordinary near one of the closest worlds beyond our solar system. Far beyond Earth, orbiting the red dwarf star Proxima Centauri roughly 4 light-years away, lies an exoplanet known as Proxima b, a rocky world located within its star's habitable zone, where temperatures might allow liquid water to exist. For years, scientists have considered Proxima b one of the most promising nearby candidates for life beyond Earth. But recent infrared observations have sparked an entirely new level of curiosity. During extended monitoring sessions, astronomers identified unusual patterns of faint infrared light appearing from the planet's dark hemisphere. Unlike random flashes caused by storms or volcanic eruptions, these emissions appeared strangely organized, rhythmic, repeating, and unexpectedly stable over time. At first, researchers assumed the signals were likely observational noise or natural atmospheric activity. But as additional data accumulated, the patterns remained. That persistence is what made scientists pause. Proxima b is believed to be tidally locked, meaning one side permanently faces its star while the opposite side remains in constant darkness. If intelligent life ever evolved there, the night side of the planet could require artificial illumination or advanced energy systems to support civilization. And that possibility, however speculative, has transformed these observations into one of the most debated mysteries in modern astronomy. The detected emissions do not resemble typical auroras or chaotic thermal activity. Instead, the brightness appears to fluctuate in structured intervals, patterns some researchers compared to how large urban regions on Earth appear from orbit at night. No one is claiming proof of alien civilization. But the observations are unusual enough that scientists are now demanding deeper investigation. Understanding the mystery requires understanding the environment of Proxima b itself. Its parent star, Proxima Centauri, is a red dwarf, smaller and cooler than the Sun, but also far more volatile. These stars frequently unleash powerful flares capable of bombarding nearby planets with intense radiation. Many astronomers once believed such conditions would strip atmospheres away entirely, leaving surrounding planets barren and hostile. Yet Proxima b may have survived. If the planet possesses a sufficiently thick atmosphere or strong magnetic field, it could potentially shield its surface from radiation while maintaining stable temperatures across certain regions. And if liquid water exists there, even beneath clouds or ice, then the possibility of life becomes far more difficult to dismiss. The strange light patterns are only part of the mystery. Astronomers studying Proxima b's atmospheric chemistry have also identified unusual gas ratios that appear difficult to explain through simple natural processes alone. Among the most intriguing findings are elevated methane levels without the expected amounts of carbon monoxide. On Earth, methane is strongly associated with biological activity in industrial systems because it is constantly produced and replenished. Without ongoing processes, methane eventually breaks down. That means something on Proxima b may be actively maintaining its atmospheric chemistry. There are several possible explanations. The first is biological activity, perhaps microbial ecosystems or unknown life forms interacting with the atmosphere in ways similar to Earth's biosphere. The second possibility is technological. An advanced civilization could theoretically influence atmospheric composition through industry, energy production, or large-scale environmental engineering. Some scientists have even proposed that the observed infrared pulses might not be city lights at all. They could instead originate from orbital structures, giant reflective satellites, energy collectors, or directed communication systems using modulated infrared signals. Civilizations living on a tidally locked planet might need massive technological infrastructure to survive harsh environmental conditions. Imagine enormous orbital mirrors redirecting sunlight toward the dark side of the planet, or vast underground cities powered by geothermal systems beneath the surface. While these ideas remain speculative, modern telescopes are finally becoming powerful enough to seriously investigate them. Detecting a planet next to its host star is extraordinarily difficult. Stars outshine their planets by billions of times, making direct observation nearly impossible under normal conditions. The James Webb Space Telescope overcomes part of this challenge using advanced infrared instruments and starlight suppression techniques that allow faint planetary signals to emerge from overwhelming stellar brightness. Future observatories may go even further. Upcoming projects like NASA's Habitable Worlds Observatory and next-generation telescopes on Earth could provide dramatically sharper observations of nearby exoplanets. Technologies such as star shades, giant structures designed to block starlight in space, may eventually allow direct imaging of Earth-like worlds around neighboring stars. If future observations confirm that Proxima b truly emits organized artificial-like light, the implications would be historic. Humanity may discover that intelligent life exists not across distant galaxies, but practically next door on the cosmic scale. A civilization orbiting the nearest star system. Perhaps watching the universe just as we are. Of course, scientists continue urging caution. Extraordinary claims require extraordinary evidence, and natural explanations must be ruled out before any conclusion can be taken seriously. The signals may ultimately turn out to be unfamiliar atmospheric physics, geological processes, or observational artifacts not yet fully understood. But regardless of the final explanation, something important has already changed. For the first time in history, humanity possesses instruments sensitive enough to search distant worlds not only for planets and atmospheres, but for possible signs of activity. The universe is no longer just a collection of distant stars. It is becoming a landscape of worlds that can be studied, analyzed, and perhaps one day understood. And somewhere in that darkness, beneath alien skies orbiting another sun, strange lights continue to flicker, waiting for humanity to discover what they truly mean.